Hello, welcome to this lesson in AC analysis. Here we're going to talk about the units of real and reactive power. I almost just tacked this on at the end of the last lesson and just threw it in there, but I really wanted to break it out and make sure that you could see it all on its own, even though some of it's a repeat, because I think it's really important that you understand. The number one thing to realize is that all of the stuff we've talked about comes from this equation, and this equation is the instantaneous power, and it comes from multiplying the current times the voltage. Now, we've identified these first two terms as having to do with the real power, right? And we've identified this third term as having to do with the reactive power. In fact, Q is actually the coefficient of this term right here, right? And so because these guys come from current times voltage, the units of P and Q have the same dimension. Okay, they have the same dimension because they all come from a multiplication of current times voltage. So what I mean by that is capital P, okay, which is P plus P cosine 2 omega t like we've talked about. That's what we called, let me erase this there. That's what we called real power. So when you see in your problems, P is equal to whatever, you automatically know it's real power, it's resistive, all right? What do you think the units of that is? The units is what we've always used for power, watts. So in AC analysis, when you're dealing with real power, you're still talking about watts. But what I've been trying to tell you is that since this is all part of the same equation for instantaneous power, the unit of Q here is really the same as the unit of P. So really, the unit of Q could be watts also. But that would get really confusing because then you're going to talk about, well, 65 watts of real power and 65 watts of reactive power. And then sometimes Q can be positive or negative depending on if it's an inductive or a capacitive case. So then you're going to have negative 65 watts of reactive power. That's going to get really confusing. So we actually have a new unit that we use to discuss reactive power. All right, but it's important to keep in mind that there's nothing different about it. It could still be called watts, okay, but we just don't because it gets confusing. So what we are going to call this for Q, this is the reactive power, and the units are something called VAR. VAR. And that stands for volt, amp, volt-amp, reactive. The volt amp comes from, because this is a power calculation, volts times amps, right? And the reactive is trying to tell you it's a reactive part of the power that comes from volts times amps. That's what it means. But the reality of it is in real life, when you see something with the units of watts for power, then they're generally talking about real power. Real power dissipated in the resistive parts of the load, okay? Real power that's gone from the system. And then this VAR, the VARs, you might call it, you might hear VARs. Oh, this motor has, a power, blah, 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 59 VARs, okay? That's the reactive. That's just reactive. That stuff's not dissipated. That's the sloshing part of the power. That's power we're putting in and taking out, putting in and taking out, putting in and taking out to the load because of inductive or capacitive effects like we've been talking about. So this is how we distinguish them, but it's important to know that it's really the same dimensions. We just totally rename the units instead of calling it watts so we don't get confused. So for instance, just kind of a little review here, recall that Q is Vm Im over 2 times the sine of theta V minus theta I. Okay, the unit of Q here is now, for henceforth, going to be VAR. That's what you're going to call it all the time. Don't put watts there because then people get confused and they're like, this isn't even real power. Why does he put watts there? So if you put watts there, it's going to be totally confusing. Put VARs there. That's the unit of Q. Okay, and then just a little more of a review. I'll kind of stick over here just to have it in one place to drill it in